Welcome to Future Epoch, where we learn more about our world. On the morning of October 29, 2018, Lion Air Flight 6110 lifted off from Jakarta, Indonesia. 12 minutes later, it plunged into the Java Sea. All 109 people on board were killed. 5 months after that, Ethiopian Airlines Flight 302 departed Addis Ababa and crashed just 6 minutes into its flight, killing all 57 passengers and crew. Both aircraft were Boeing 737 MAX jets. Both crashes were caused by the same system, a piece of flight control software called MCAS, and both disasters were preventable. What followed was not simply an aviation safety crisis. It was the slow unraveling of one of the most powerful aerospace companies in history, a story about what happens when a great engineering organization stops prioritizing engineering. Boeing was founded in 1916 and spent most of the 20th century as the definitive symbol of American industrial ambition. For decades, it was regarded as one of the finest engineering organizations on Earth. Its engineers built the 747, the aircraft that democratized long-haul air travel. It built machines that defined what modern aviation looked like, and its reputation for safety and precision was considered essentially unassailable. The 737 itself dates to 1967 and has been in continuous production ever since, making it the best-selling commercial aircraft in history. By the time the 737 MAX variant entered service in 2017, Boeing had accumulated orders for more than 4,000 of them. The MAX was supposed to be the fuel-efficient evolution the airline industry needed, a familiar aircraft with modern economics. Instead, it became the centerpiece of the worst safety crisis in Boeing's history. To understand the crisis, you have to understand the competitive pressure Boeing was facing in the early 2010s. Airbus had launched the A320neo Vinder, a re-engined, fuel-efficient version of its own best-selling narrow-body jet, and airlines were switching allegiances fast. American Airlines, which had historically bought exclusively from Boeing, placed a large order with Airbus. Boeing needed a response, and it needed one quickly. Rather than design an entirely new aircraft, Boeing chose to re-engine the existing 737, fitting it with larger, more fuel-efficient CFM LEAP engines. The engineering difficulty was immediate. The original 737 sits low to the ground, and the new engines were too large to mount in the same position under the wing. The solution was to move the engines further forward and higher on the airframe, but this changed how the aircraft handled. Under certain conditions, the nose would pitch upward unexpectedly. Boeing's answer was MCAS, the Maneuvering Characteristics Augmentation System, a software layer designed to automatically push the nose down when sensors indicated a risk of stall. It was, in principle, a reasonable engineering response to a known aerodynamic limitation, but the execution contained fatal flaws. MCAS relied on input from a single angle of attack sensor, with no cross-checking against a second. If that sensor malfunctioned, the system would activate repeatedly and with increasing force, pushing the nose down against the pilot's attempts to recover. Crucially, pilots were not adequately informed that MCAS existed. Boeing's documentation minimized its significance to the point of exclusion from flight manuals, and the FAA's certification process, which had delegated substantial authority back to Boeing's own designated engineers, did not identify the gaps. When Lion Air Flight 6110 entered a sequence of MCAS activations, the crew had no knowledge of what system was fighting them, no effective procedure to counter it, and fewer than 12 minutes before impact. The Ethiopian Airlines crash in March 2009 forced a global grounding of all 737 MAX aircraft. The FAA was among the last regulators to act, following aviation authorities across Europe, China, and much of the rest of the world. That delay drew sharp criticism from airlines, foreign governments, and legislators. A subsequent congressional investigation, released in September 2020, described a culture of concealment and a fundamental breakdown in Boeing's safety oversight. The report found that Boeing employees had raised concerns internally about MCAS long before either crash, and that those concerns had been minimized or dismissed. it found that the FAA's oversight model, which allowed Boeing engineers to self-certify aspects of their own aircraft's airworthiness, had failed in precisely the way critics had long warned it might. And it identified a broader cultural shift within Boeing that had made safety secondary to schedule and cost reduction. That cultural shift had roots going back to 1997, when Boeing merged with McDonnell Douglas. What followed, across the next 2 decades, was a gradual migration of Boeing's leadership away from its engineering centers and the consolidation of a financial management philosophy that prioritized shareholder returns over long-term engineering investment. Engineers who raised concerns found themselves sidelined. Production schedule pressure intensified. The question of whether an aircraft was ready increasingly competed with the question of whether it was profitable. CEO Dennis Muilenburg defended the aircraft publicly even as investigations were ongoing, insisting MCAS had been properly designed and implemented. By December 2009, with the grounding extended indefinitely and Boeing's credibility in freefall, he was removed. The aircraft did not return to commercial service in the United States until November 2020, after Boeing agreed to extensive software redesigns, mandatory enhanced pilot training, and new certification conditions. By that point, the grounding had cost Boeing more than $20 billion and permanently altered the commercial aviation market. The consequences extended far beyond the immediate financial losses. Suppliers across Boeing's production network faced severe disruption, with Spirit Aerosystems, which manufactured the MAX's fuselage, struggling to maintain workforce and capacity during the extended grounding. When the MAX returned to service, production rates proved painfully slow to rebuild, and quality problems persisted on factory floors that had been destabilized by years of financial pressure and workforce reductions. Then, in January 2024, a door plug panel blew out of an Alaska Airlines 737 MAX 9 at 13,000 feet. By coincidence, no passengers were seated in the adjacent seats, and no fatalities resulted, but the incident reopened every question that the 2019 reforms were supposed to have answered. Federal investigators found improperly installed bolts. The FAA announced a production cap and launched a comprehensive audit of Boeing's manufacturing processes. The results documented systemic failures in documentation, part traceability, and quality control across multiple production lines. Boeing's CEO, Dave Calhoun, announced his departure in March 2024. The company reported further billions in losses. Airlines sought compensation for delayed aircraft and disrupted fleet plans. The reputational damage that had seemed manageable in 2021 had hardened into something structural and far more difficult to reverse. The Boeing crisis is not simply a story about software failure. It is a story about institutional failure, about what happens when the structures designed to catch errors are themselves compromised by the pressures they are supposed to resist. The FAA's certification model assumed that Boeing's internal safety culture would function as a reliable check on its own commercial incentives. By the evidence of multiple independent investigations, Boeing's internal culture had stopped functioning that way, not suddenly but gradually, over many years, through a succession of decisions that each seemed manageable in isolation. What the story reveals is that safety systems are only as strong as the organizations that operate them. When regulatory oversight is delegated back to the regulated company, and when that company's culture systematically deprioritizes the findings of its own engineers, the result is not a single point of failure. It is a systemic one. And systemic failures are harder to detect, slower to correct, and far more costly in every sense. Boeing remains one of the largest aerospace companies in the world. The 737 MAX continues to carry millions of passengers every year, and the reforms demanded after 2019 have, by most technical assessments, made the aircraft meaningfully safer than when it first entered service. But the deeper questions raised by the crisis have not been fully resolved. Can a company the size and complexity of Boeing genuinely rebuild an engineering-first culture after decades of institutional drift in the opposite direction? Can regulators who rely on industry self-certification ever fully correct for the conflicts that arrangement creates? And when the costs of catastrophic failure are distributed across shareholders, insurers, airlines, suppliers, and regulators, who ultimately bears the weight of accountability. The 36 people who died on the Lion Air and Ethiopian Airlines flights never had the opportunity to ask those questions. But the rest of us now have to is Boeing's most lasting and most difficult legacy. Thank you for watching. If you've enjoyed this content and want to see more, please consider liking the video and subscribing to the channel.